Okay, let's solve another differential equation with initial condition. So the differential equation given here is y prime equals to x minus xy, and the initial condition is y at 1 is 0. It means that when x is 1, y is going to be 0. So when you have a differential equation with initial condition, what you do is first find the general solution. When you're done, you have a solution with some c somewhere. This is a family, and then the second step is that use the initial value to find a particular solution. Okay, so let's start finding the general solution or solving the differential equation. When you look at this differential equation, at the first glance, it seems that we cannot separate. There's a minus sign there. But if you look a little bit carefully, you'll notice that we can factor x, and I can write this as product of two things. One is function of x, another is function of y. So the right hand side is product of two functions, one in x, one in y. That means that the equation, the differential equation, is separable. And when we have separable differential equation, we need to take two steps. One, separate the variables, means that the y terms, everything in terms of y, put it in the left hand side, and x terms, put them in right hand side. Okay, so we have left hand side, right hand side, and now we have to do it here. Okay, so to be able to do everything nicely, I need to write y prime as dy over dx. This is always when you have separable differential equation, you change y prime to dy dx, and then x 1 minus y. Okay, then I can divide this down there and multiply dx upstairs, and as a result we have 1 over 1 minus y dy is equal to x dx. Very nice. Step 2 now is that now that you separated, integrate both sides. Integrate both sides. The left hand side will be integral of 1 minus y dy, and the right hand side is going to be integral of x dx. Well, if you look at the left hand side, you need to do one small substitution. U is equal to 1 minus y, and then du is equal to minus dy. So that means that if I apply the substitution to the left hand side, I will get 1 over negative 1 over u du. And this is the same thing as negative ln of u. And well, it is the same thing as ln of, put back this guy here, 1 minus y. Okay, so the right hand left hand side is then minus ln of 1 minus y, and the right hand side, the integral of x is x squared over 2. This is an easy integral, and always try to put plus c only for the x side. So we have what we were looking for, negative ln 1 minus y equals x squared over 2 plus c. That's the general solution. Well, then let's do a little bit more. That's the first step. The second step is that we want to use the initial value. So we have minus ln of 1 minus y equals to x squared over 2 plus c. And we are trying to apply the condition. Condition is y at 1 is 0. So if you apply that, what you see here is the minus ln of 1 minus 0 equals to 1 squared over 2 plus c. And then, well, this is minus ln 1 equals to 1 over 2 plus c. This guy is 0 equals to half plus c. And then c is equal to negative half. In other words, we have minus ln of 1 minus y equals to x squared over 2 minus 1 over 2. And that gives us what we were looking for. The particular solution for this system, this differential equation. You can do a little bit more work and turn this to y, written y on one side and everything else in x on the other side, but I'm not going to change that. This is enough to solve that differential equation.